Very quick intro to confidential computing. So, the big question that confidential computing is trying to solve is how to process data securely on someone else's computer. So imagine there's your workload. It's running on the cloud, which is someone else's computer. Could be an AI workload, could be something else. And of course, you must consider different threats, right? There could be nation-state actors trying to access your data. There could be hackers inside the cloud's fabric, or there could be data center employees just trying to take memory dumps. That's a problem, and confidential computing addresses this by isolating and encrypting your workload. So how does this work? First up, the simple explanation, and then a bit more technical explanation. So most people associate a thing called runtime encryption with confidential computing, or data and use encryption. And this complements the traditional forms of data encryption, which are data at rest and data in transit encryption. So with data and use encryption, you close the circle. This is complemented by the second pillar of confidential computing, which is called remote attestation. And this may not sound very interesting at first glance, but it's very important because it allows you to verify that your workload is indeed protected and encrypted in use. And to no surprise, we have 6 talks in total about remote attestation today, and this highlights the importance of this concept for confidential computing. So it is the biggest virtual track we have today. Right? So it ranges from remote attestation for web-based services, which I personally find very exciting, to business models for remote attestation, which is also very interesting. So make sure to check those talks out. Now, a more technical view. How does confidential computing work exactly in quotation marks? Here's a picture, a diagram I have shown for the last 10 years. The first version was in my PhD thesis. And you may have seen this many times if you are part of the confidential computing community, especially OC3. So the foundation of confidential computing is a technology called confidential VM. And the idea here is that the CPU protects a virtual machine with runtime encryption and offers also remote attestation. Remote attestation means that the CPU has a private key it can use to issue certificates for the workload it is executing. The technologies that provide confidential VMs are Intel TDX, AMD SEV, and ARM CCA. So you could say it's ubiquitous on the server side. However, for ARM, there yet has to be something in the world. We haven't seen any or a lot of chips in the wild. And I'm glad to share that we will hear more about confidential computing on ARM, first in the keynote by Richard Grisenwaith, and second in a talk from Fujitsu about building a server-side CPU with ARM that has confidential computing features. Very exciting stuff. Make sure to check those out. Also, we have 3 talks about low-level and specialized software, like firmware and hardened OS software, to run inside confidential VMs from SUSE, Ubuntu, and Microsoft. This is low-level stuff, but it's super important, but because only if you have the right foundations inside the CVMs, we can have secure confidential systems. Now, the other very important foundation are confidential accelerators, pioneered by NVIDIA. In a nutshell, you can connect an NVIDIA GPU to a confidential VM and have end-to-end confidentiality. And this, of course, allows confidential AI workloads. We have a talk by Microsoft today, or by Intel, on how to create the secure connection efficiently from the CVM to the accelerator. Now that we have the foundations out of the way, here come the use cases. There are 2 classes of use cases. The first one is protection against infrastructure providers. That's pretty straightforward. And we have a couple of talks, or 2 talks, on use cases in this area. The second use case class is secure multi-party compute. And this is a bit more exotic. rather straightforward concept, very interesting, though. And there's a talk from the Swift payment system about multi-party fraud detection using confidential computing. And of course, in both cases, AI is super interesting. And you may have seen the media buzz when Apple announced something in the area of confidential AI this year. Of course, experts maybe would not call this Apple system confidential necessarily, but it showed that people really cared about this concept and that this was something that the mainstream wants. And unsurprisingly, we have a lot of interesting talks today about AI. First, there's a keynote by Daniel Rohrer on confidential AI and what NVIDIA has to offer. And then there's a joint talk by Google Cloud and Intel on the latest AI offerings they have. There's also a very interesting talk by ByteDance on the protection of model weights using AI. And there is, of course, the by now traditional industry leaders panel with the VP of software security from NVIDIA, the CTO of Intel, CTO of AMD, and CTO of Microsoft Azure discussing about confidential AI and other super interesting topics. So you will not want to miss this one. And finally, there's one announcement, or there's news from Edgeless Systems. So a couple of weeks ago, we launched our service Private Mode AI. It is the first in production end-to-end confidential Gen AI service. We're quite proud of that. It can be used just like ChatGPT from a traditional UI chat interface. It can be used via an API. And I will be giving a talk about that, about the architecture later today. And my colleague Moritz Eckert will give a talk about the contrast framework, which makes it easy to run and manage confidential containers at scale. And we build private mode on top of contrast. So these two talks complement each other. These are our most advanced products at Edgeless Systems. And of course, I highly encourage you to attend these talks. With that, the last thing I want to do is thank our sponsors, Google, Intel, Microsoft, Airbus, ARM, and the Confidential Computing Consortium. Thank you so much for making this possible and your support. And finally, I want to thank the program committee who reviewed all these 100 submissions and I think made an excellent choice and put together an excellent program. Thank you so much, everyone, and have a great OC3.